Algebra I 10.5D. Still getting over this cold. I'm sorry. My voice is still a little funny. We're going to be talking about adding rational expressions using the least common multiple for unlike denominators. So we can add rational expressions with unlike denominators by finding their least common multiple. It's the same thing as finding their least common denominator. We find the least common multiple, the LCM of the denominators. We're going to write each rational expression as an equivalent expression with their least common denominator by multiplying it with an amount that's equal to 1, like 4 over 4 or 2 over 2, and so on. When we add the numerators, then we write the sum over that least common denominator. So here's an example. If we have 2 over 3y plus 1 over 4y, well, what if the y's were not there and you were adding 2/3 and 1/4? We would need the 3 and the 4 to meet at a common denominator, wouldn't we? And it would be the least common denominator, and the 3 and the 4 can meet at 12. When we factor these, we get 2 times 2 times 3 times y for this 12y. See? What we can do is we can multiply this 2/3 y by 4 over 4. So that's the equivalent to 1 expression or amount. We'll multiply this side by 3 over 3. And then we'll get 8 over 12y, and then we'll get 3 over 12y. And now we have a common denominator, don't we? And it's the least common denominator between the 3y and the 4y. So now we can add them because the denominators are the same. So 8 plus 3 is 11. We got 11 over 12y. See? So we just need to find something that's equivalent to 1 to multiply one or both of the rational expressions so that we can get the denominators to be the same, all right? So take a look at this one. It says add and simplify. We've got x over this binomial, 4x plus 12, and we've got 2x over this binomial, 5x plus 15. Well, we have to factor these first. So when we factor the 4x plus 12, it comes out as 4 times x plus 3. Now, if you don't remember factoring, there's a link in this description to go back to the factoring playlist, okay? It's really important you remember how to factor. Otherwise, you're going to be completely confused, okay? So this 4x plus 12 is the same thing as 4 times x plus 12, see? 4 times 3. And then this 5x plus 15 is 5 times x plus 3 when it's factored. So now they're factored, and we can find that the least common denominator for these is going to be 4 times 5 times x plus 3. See? So we need to meet at 20 times x plus 3 because of that 4 and that 5. See? Here's the 4 and here's the 5. So we need to meet at 20 times x plus 3 in order to add these two rational expressions. Well, what does this one need to get to 20? It needs to be multiplied by 5, so we multiply the numerator and the denominator by 5. That's the 5 over the 5. That's the 1, see? And then this one needs to be multiplied by 4 in order for this to get to 20 times x plus 3. So we have to multiply the numerator by the 4, see? So we end up getting 5x over 20 times x plus 3, and we get 8x times 20 over 20 times x plus 3. See how we did that? We just add the 5x and the 8x and get 13x, and it's over 20x plus 3. And it's simplified. We're done. Let's try another one, okay? I'm going to add and simplify this one, 7 over 3x plus 15 plus 4 over x plus 5. So we have to factor this one first. We can't factor this one. That's as low as it's going to go. But we could factor this one, put a 3 on the outside of the parentheses, and multiply it by x plus 5. That'll get us 3x plus 15, won't it? We just drop this guy down. Now that it's factored, we can find that the least common denominator is going to be 3 times x plus 5. So now this one needs to get to 3 times x plus 5, don't we? So the only way to do it is to multiply the numerator and denominator by 3. That way, its denominator will be also 3 times x plus 5, see? So we leave this one alone, and we just multiply this one by 3 over 3 as our equivalent to 1 that we're multiplying it by, and we end up putting the x plus 5 in parentheses, and now we have 3 times x plus 5 on this side too, see? And that becomes a 12 up here, doesn't it? And 7 over 3 times x plus 5 plus 12 over 3 times x plus 5 is 19 over 3x plus 5, see? Let's try it with one a little bit more difficult, okay? Now we've got 2x over x squared minus 1. We're going to add it to a negative 1 over x plus 1. Now we know this one's prime, isn't it? But this one can be factored, right? It could be factored as x plus 1, x minus 1 multiplied to each other, right? Like a binomial. See? So we need to meet here at this x plus 1 times x minus 1. So what do we need to do to this one to get it to look like that? So now this is factored. We have 2x over x plus 1, x minus 1. And we need this one to have an x minus 1 over here. So we multiply the top and the bottom by the x minus 1, so this one has the x minus 1 as the denominator, see? Then we use the distributive property with this negative 1 to the x and negative 1 times negative 1, and we get negative x plus 1, because the two negatives made a positive 1, see that? Now we add the numerators and keep the same denominator, 2x plus negative x plus 1. Well, 2x minus x is just x. Remember the invisible 1's there? So we're taking one of the two x's away, so now we're just down to 1x. So now we have x plus 1 over x plus 1 times x minus 1. See? And we've got an x plus 1 over an x plus 1, don't we? And that could be canceled out. Well, x plus 1 is the same thing as 1 times x plus 1, isn't it? Just like 5 is the same thing as 1 times 5, isn't it? So that way we can have a numerator. So by saying it's the same thing as 1 times x plus 1, we can cancel these guys out and have 1 over x minus 1. See? See how I did that? Okay, so remember, if one of the add-ins is a whole number when you first start out, you can just rewrite it as a fraction. So if it says 5 plus 7 over 3x plus 15, you can write that 5 as a rational number by putting it over a 1, couldn't you? And even if it was 5x, you could put it over 1. If it was 5x plus 15, you could put it over 1, couldn't you? To turn it into a rational number so that you could find common denominators and go straight across, right? So remember the factoring videos are in this description. We're going to go to 10.5e. We're going to talk about how to subtract unlike denominators for rational expressions using this least common multiple method, least common denominator. If you want to go back to see any of the previous videos for factoring or how to even find a least common multiple of rational expressions or how to multiply or divide them, or adding them when their denominators are the same, all those links are going to be in here, okay? I'm really sorry about my voice. It's taken me quite a while to recover from this cold. It's been a couple weeks, and so I'm down to just loading one video a day because I'm just not up to doing as many as I used to. So hopefully I'll be feeling better, and I hope you're feeling okay. I hope you're doing all right, and I'll see you next video. Bye.